Hello and good day, everyone. My name is Dion LeCointe. I am the Senior Manager for IP Solutions at Sony Electronics Imaging and Professional Solutions of America Division. We are going to go ahead and get started with our webinar today entitled Broadcast 2.0, REMI and Centralized Production. I will be presenting alongside my colleague Jason Weintraub. He will be presenting a little bit later on in the webinar. And we really want to focus today on the burst in the market and the trend of remote production, also known as remote integration or REMI, and also the idea of centralized production. These trends, these topics that have been going on in the industry are really being driven by the advent of IP technology and the rollout of IP solutions for live production or IP for media. Many of you have heard this go through a number of different iterations. Back in the day, we had SMPTE 2022-6. Then you've heard of other vendor-developed solutions like NMI, the Network Media Interface developed by Sony, Aspen, developed by Evertz. Then you heard of other names like TR03, which eventually became SMPTE 2110. And now that SMPTE 2110 has really rolled out and people are implementing it, we have a number of installations on a worldwide basis. We're really looking at not only just the rollout of IP solutions, but also the applications and the different implementations that can be put into place because of the IP technology and the flexibility that it's offering to the market. So today's webinar will really focus on those applications. We're going to talk a lot about Sony's implementation of SMPTE 2110 as a standard, the way the industry has rolled it out. We're going to talk about Sony's IP live production system. An IP live production system is not different from SMPTE 2110. This is Sony's moniker, Sony's name for our product portfolio, the umbrella of products that all support the IP technology, including SMPTE 2110, because Sony has been a major part and a major contributor to the development of the SMPTE 2110 format and the IP formats and standards that exist in the world today by virtue of our participation and our leadership in the standards organizations such as the EBU, AMWA, and JTNM, the Joint Task Force on Network Media. Sony's strategy has always been COTS-based. We are heavily focused on commercially off-the-shelf equipment, commercially off-the-shelf network switches from major vendors like Arista, Cisco, Juniper, and Huawei. By working with these vendors, we can now take advantage of their development roadmap and how quickly and efficiently they're developing much faster network technology developed for data center applications, developed for enterprise and corporate applications, which we can now reap the benefits from and implement in a live production or media environment. So this all kind of started with a very interesting or very simple concept. Sony looked at a production facility, and we understand that in a production facility, there's primarily two sides of the house. You have the live production side, which you'll see on the left on the diagram in front of you, which includes your news studio, your program studio, satellite studio, and your production truck. And then you also have your production or news production side of the facility. And this is where you're going to find your nonlinear editors. This is where you're going to find your archive system and your transmission system. And for many, many years, they've operated on very, easy to understand, very easy to implement technology. The live side of the house has been traditionally SDI based. This is where you're going to find your coaxial cable. This is where you're going to be able to implement your HD SDI, your 3G SDI, and even today your 12G SDI technology. And that had a lot of value. That was a very easy system to implement. It gave you a number of key attributes, including seamless switching, constant bit rate, one-way directional signals, constant latency. But it did have a downfall. It didn't expand very well. The analogy that we like to use here, or the comparison that we like to use, is the growth and the transition from an HD environment into a 4K environment. So today's broadcast facility that's running in HD, that is running 1,000 by 1,000 SDI router, when that scales up to 4K, that router effectively only becomes 25% usable. So now you're looking at 250 by 250. And by most broadcast standards and by most broadcast business models, that doesn't work for the broadcaster. That doesn't work for people who need to scale up and scale down their system at a moment's notice from HD to 4K or other formats that could be coming in the future, like 8K. So we draw the analogy to a train system with SDI, because you knew that as long as that cable worked, that your signal was going to get from its source to its destination. So just like a train, as long as that track is in place and the track isn't broken, that train will get from its source to its destination. The issue runs into expanding that system. The issue runs into putting down more tracks to allow for more trains, to allow for more traffic. How do you expand that system? You can do it, but it is not easy to implement. It is not easy to do. Then you flip the coin and you look at the other side of the facility, which is the production side. And this has primarily been network-based for a long time. Like I said, this is where you'll find your nonlinear editors and you'll find your file-based operations. And they've been using network switches, COT switches for a long time. You're going to find your Cisco's, your Junipers, your Huawei's, your Arista switches on this environment. And they've had the benefit of high expandability. So drawing the analogy to a freeway is that you may have a 4-lane freeway. If you need to support more cars, you need to support more traffic, you can then expand the freeway. You can expand from 4 lanes to 6 lanes to 8 lanes and so on. That gives you the ability to support more traffic, to support more activity on your environment. The kind of downfall, the disadvantage of the post-production side has always been that it's best effort only, and that you don't have a guaranteed latency, you don't have guaranteed sync. So it's pretty much going to get the signal there when it can. And even though you have the fastest, most powerful network switch or fastest network topology on the market, the laws of physics are finite. You may not run into the same slowdown you did when you had a slower switch, but you are going to run into some type of slowdown where every user and every application on your network is on the network at the same time, moving data around the network. So the goal has been to merge the benefits of both of these two implementations. How do we get the constant bit rate, constant latency, and guaranteed delivery of an SDI environment, but also get the high expandability of a network-based environment? And that's really where the strategy has been. That's really where the vision has been. And that's what's bringing us to where we are in the market today. We take a look at a very simple implementation of an IP system, which looks very similar to this, which is all of your live production endpoints reside on the network. So you have your cameras, you have your servers, you have your peripheral devices for conversion that are going from SDI to IP and vice versa. You have your production switchers, you have multi-viewers, and so on. And then at the top level, you have your control. You have your live system manager, which is your broadcast network controller, and a new solution, which we'll talk about a little bit later today, called the Live Element Orchestrator. We're very happy that Sony's entire portfolio of live production products are IP enabled. So if you take a look at this diagram, which shows the different segments as we've broken it up, you have operation, you have the IP network, you have acquisition, production, and processing. Starting with operation, right in the middle is the IP Live System Manager. That is our broadcast network controller. The broadcast network controller represents the brains of the entire operation. It is what is controlling all of the flows of video through the IP network. It's what's controlling the control signals going through the network to all of the edge devices that exist in the network. It acts as a router. It's where you can do setup and configuration of your devices. You can set the AV format of your devices. You set up users here. You also can set up device authentication, network authentication. It does bandwidth reservation. It does QoS. It really is controlling everything that's going on in the environment as it relates to getting the bits of data, the streams of video, audio and video, to the edge devices or from the edge devices to their relevant destinations. Immediately to the left of the Live System Manager, we have some control panels. Those are the NS bus panels. And these panels are pretty reminiscent of Sony's S-Bus panels, and they're aux panels or they are router control panels. So in addition to having the software-based GUI that you would find on the LSM, the Live System Manager, where you can actually change your cross points feeding to your various destinations from your various sources, you also have a hardware-based option where you can dial up your source and feed them to the destination. To the far right is the Live Element Orchestrator. That is a new software-based orchestration tool for live production that I will talk to a little bit later in the webinar. And then if we move down, we're just showing that we have support across the board for the major network switch developers like Arista, Cisco, Huawei, and Juniper. And then as we move into the various endpoint devices, we look at acquisition. And by virtue of our CCU and BPU support of IP technology, our entire HDC 3000, 4000, and 5000 series cameras are supporting SMPTE ST2110. The 2000 series also supports SMPTE 2110 by virtue of the HDCU 3100 or HDCU 3170. So Sony's entire camera lineup can be run in a full end-to-end IP environment. Moving to the middle, where you look at production, you see Sony's XVS series of switchers, starting from the XVS 6000 all the way up to the XVS 9000, are built from the ground up to support IP and also support 4K end-to-end production. Right below that is our PWS 4500. This is our 4K and HD production server that can be used in a replay or ingest or playout server configuration. We see a lot of the servers deployed for sports. We see a lot of the server being deployed for entertainment to record 4K content. That has a SMPTE 2110 option board as well, so you can do SMPTE 2110 in and out from the server. And then moving over to the right, you'll find what we call processing or infrastructure gear. This is where you're going to find the FR316, which is a housing unit for the card that you see down below, which is the NXLK IP50Y. This is for support of what we would call, and I use the term loosely, legacy support. Any hardware or any products out there that are SDI enabled and will only be SDI, but you need to convert to IP, the IP50Y can convert those signals to IP, SMPTE 2110, and vice versa. We can go back from 2110 back to a baseband SDI signal as well. In the middle, you see some of Sony's transceiver modules. We do offer a 10 gig, 25 gig, and 100 gig transceiver option. Each of these transceivers are multimode. There is a single mode transceiver that's on the way as well for the 25 gig, but I want to point out that these are not specific to Sony hardware and we do not vendor block. So you don't have to use Sony transceivers when you are implementing your IP system. We do guarantee a certain level of performance. We do guarantee performance with our hardware if you do use our transceivers, but we are open. We do, again, support a COTS architecture. So you can use transceivers from other vendors as well inside of our products. Taking a look at this overall portfolio as well, we're also very happy to be supportive of full 1080p and 4K and HDR in all of our products that also support the IP technology. Sony has an extensive amount of experience implementing IP systems. We now have more than 50 installations worldwide that include a mix of studio systems and outside broadcast trucks or OB trucks. And because of this experience, what we're really seeing is, again, the explosion in the desire for more and more clients, more and more customers to implement a remote production or REMI style system. This could be argued, but it's very easy to say that this kind of rolled out first in the sports production world and on the OB production truck, because the concept was, well, if I can connect my brick and mortar broadcast facility to a remote stadium or a remote location, maybe I don't have to send the same full production truck to that site to cover the event and bring it back to the main broadcast facility. Maybe I can reduce my broadcast complement on that truck, and I only need to deploy talent, I need to deploy cameras and audio, but maybe now the production switcher stays back at home. Maybe the audio console stays back at home, or other elements of the production that traditionally would be on the truck would be deployed, but they can now remain at home. So a number of clients, a number of partners have looked at making that production truck complement much smaller and sending a sprinter van or sending a smaller complement of equipment to the remote site, and then sending the signals back via IP, like something like SMPTE 2110, to the main broadcast facility. That is, at its very base level, one aspect of implementing a REMI system. We took the concept a little bit further and we thought of, well, if it's IP and everything is connected, well, why couldn't you use those resources more efficiently? So one of the features that exist on our existing XVS series of switchers, like the XVS 9000, is a feature called resource sharing, which is taking a single switcher processor, a single physical switcher, and splitting that switcher into two logical switchers. So here we have an example where an XVS 9000 has been split into two logical switchers. Logical switcher 1, which could be running in HD, is now serving control room A and studio A, and logical switcher 2 of the XVS 9000 is serving control room B and studio B. That's a more efficient utilization of the switcher, and that switcher can really live anywhere in your facility or anywhere in your network. To talk a little bit more about our remote production support and our REMI style operations, I'm going to hand over this portion of the webinar to Jason Weintraub, and Jason will be able to run through with you some other examples of where REMI becomes useful and by virtue of implementation of IP. Jason?
Thank you, Dion. Hopefully you can see my screen now with my heads up. Is that correct?
Yes, we can.
Just make sure excellent, thank you. So thanks, Dion, and thanks for the overview on everything. Hopefully that was a really helpful start on where we are within the hardware and how we can help develop a more efficient workflow for our resources. What I would like to talk about is a little bit also the fact that in addition to the hardware efficiencies that we are working for, we're also working on solutions hardware and solutions that we can do to be more efficient with you in helping you move your productions to the next level. So what I would like to talk about briefly is that we have this conventional broadcast production, and in a typical broadcast production workflow, you have cameras, your monitors, your any news program content, in the field content, your production switcher, graphics, servers, and an IP switch, essentially what you have today. Years ago, of course, in an effort to increase efficiency in workflow, we created a product that I'm the product manager for, which is the ELC, or Enhanced Live Control, which allowed us to automate some of the workflows that we were doing to allow us to either create more productions without increased cost or a decreased cost to do our productions. A variety of different formats that ELC does include news, faith-based, religious things, sports, we're into the sports market. So any type of production, and really ELC is designed to be free-flowing, so it's not necessarily a scripted type of variety of show. And that is where we went with ELC and broadcast. Just to give you an idea of where we are currently, this is just a map of some of our installations. You'll notice that we are very heavily concentrated in the very large TV markets. And also now we're spread across from both large to small. So we've hit a really good opportunity now of both device control, teleprompters, lighting boards, and things, and a widespread of customers and clients and types of applications that we're in use for. What we're looking at now is how do we create this efficiencies that we've created with ELC for our customers on the solution side, not necessarily only the product side, but to extend it to help you create additional workflows and efficiencies. And one of the things that we're looking at that we are implementing is remote or automated production. Now there's a few different models here that we have, and I just want to show you what we've got. This one is an example of, I've got two television stations. I've got station A and I've got station B. Both of them are a TV station on their own and completely capable of doing a broadcast. With ELC currently, most stations will have the ELC operator, the director, if you will, at each of the facilities. So that person would typically, and when I worked in the television stations, I would work on a specific shift. I would work from 3 to midnight. I would work essentially on newscasts from 4 to 6:30, and then I would be back on at 11 to 11:30. But that gap between 6:30 and 11 is really time that there was not anything specific for me to be doing within that window. Our concept here is, what if we were to move ELC to a centralized regional broadcast facility and allow remote control of the individual stations? That would open up an entire new set of efficiencies, of which I'll show you here as we look at our other model as well. But what we're suggesting here is that using extending the REMI and the IP style that we're suggesting, we can extend the program signals and the signals over a multi-viewer to a centralized facility and allow an ELC operated REMI style or IP style show in a centralized facility that essentially takes all of your directors into one facility. That means that today I might be doing a show in Dallas, but tomorrow I could be doing a show in Chicago, or I might be doing a show in a very small market somewhere in between the time zones. In the field contribution, of course, our remotes using XD-Cam Air and some other types of microwave or satellite can be received at either the station or the regional broadcast center. To again further push the concept that we can move towards a REMI style broadcast with new efficiencies that we haven't yet explored. Another style that we're looking at right now is a centralized workflow. So as Dion mentioned previously, if you were to have a switcher such as an XVS 9000 that we can split physically a switcher into logical switchers, what would it look like if we were to orchestrate the use of that switcher, those playback production servers, such like Hive, like our editing capabilities, our graphic system, any graphic system that we work with, of course, and we were to centralize that equipment into a centralized regional broadcast facility, and the only thing at the local affiliate level or the local station would be the cameras that are feeding the video signals back with the embedded audio of the microphones that are in studio. Any studio monitor feeds that go back to the studio, but all the video is really being switched and processed and handled in this regional broadcast center. So in this model, XD-Cam Air and Hive, all the editing is web-based. It's all done and prepared. And then on a show-by-show level, we're getting better utilization of the equipment that's been purchased so that we can do more productions out of it, and we're able to better utilize that hardware as well. So that's another style that we're looking at. And then, and what are the benefits? Well, the benefits of this are, of course, flexible breaking news. Now I have a team of directors or show ambassadors, if you will. Those ambassadors are able to do any show from any of our local stations from a centralized facility, and you get that same high level of production quality in all of your markets, whether it be New York or down to a very small state, middle of America, as we say. You're going to get the same high level of production because we have the same equipment available to each of them to check out if we do facility management and resource management. And we also have the same directors that are doing our very, very high level shows, getting more utilization out of that crew, and they're doing other shows that might be able to benefit from time zone changes. So now as a director in ELC, I can do the 5 o'clock show in Chicago, I can do the 5 o'clock show in Seattle, because 2 hours later, I've got plenty of time to prep and do shows in multiple time zones. It also helps me to handle breaking news, because the 5 o'clock news that's occurring in New York is only 2 o'clock in Seattle. So a director in Seattle can assist across the border. So what we're doing is we're closing the loop and find new efficiencies with our equipment. This also helps reduce CapEx costs. It also does provide better staff utilization for areas that we haven't yet gone into, such as engineering personnel. There doesn't have to be the same level of expertise at each of our local stations, since the only thing there at the edges would be the things that are required, the cameras and the monitors, not also editing platforms, microwave satellite receivers, as well as graphics platforms. We also feel that this can provide better disaster contingency, because now there's less people that have to be on-prem, and it's very, very simple to launch ELC from a centralized facility or any of your facilities and be able to handle the broadcast from to a remote facility as well. What this might look like as an example, if we were down in looking in Texas, it would be very, very simple for someone in Dallas to create multiple broadcasts, each unique, each with their own your flavor and their own talent, but the centralized processing of that workflow. And for the questions of are we doing this, we are actually doing these. These are very good for us and for you as we're working on these types of projects. They're not really necessarily products out of the box. We are working with customers now for projects, and we have one right now that we're doing with ELC where we are doing remote cameras in studios, just as we mentioned in one of the prior slides, where we will be doing the broadcast from a centralized workflow, but the cameras and the monitors are all going to be controlled over an IP connection over a company WAN, if you will, to a remote facility, which will have just the cameras and the studio monitor feeds with embedded audio. So as we continue to do more and more of these projects, we find that we are moving towards our XVS line of switchers, which has IP control of switcher rows, ELC, which will have an HTML5 ActiveX so that we can do our template and code creation and prep the shows. Everything we're moving towards is heavily on that new IP infrastructure, not only on the hardware side, but the workflow and the efficiencies as well. Dean, I'll go ahead and hand it back to you. And if there are any questions, we can certainly answer those as we move forward.
Thank you very much, Jason. I greatly appreciate it, and thank you for the information. I did not mention this at the very beginning of the presentation, but if anyone does have any questions, please feel free to use the chat window in the webinar interface, the GoToWebinar interface, and send chat to organizers and panelists only, and we will receive your questions. And at the end of this, we will be addressing any questions that may come up. To follow on to what Jason just presented, we do want to talk about how this gets augmented even further, because the concept here is, the concept here is, as Jason just described, the ability to connect multiple studios together using a pool of shared resources. So if you look at this diagram here, where you have a machine room, where you have your signal, your switcher, you have signal processing, multi-viewer processing, character generator, servers, audio processing, etc. Everything is connected via IP to your IP switch from the vendors that we mentioned before. Now you have the benefit of Studio 1 and Control Room A utilizing the same hardware as Control Room B and Studio 2. Now, this is a pretty simple implementation because you are taking advantage of a feature on our switcher like resource share. Maybe you're able to schedule it where Studio 1 and Control Room A are using it from 8 a.m. to 12 p.m. And then Control Room B and Studio 2 are using it from 2 p.m. to 6 p.m. Now, what happens though when you want to expand that system? Because in this environment, it's very easy to manage with your broadcast network controller, like our live system manager. You'll have visibility to all the resources that are connected. You'll have the visibility to how they're connected to the network, and you can route the signals. It's very easy to create a salvo or a macro within your broadcast network controller, or quote unquote your router, to get you in a simple environment like this. But what happens as you start to expand? What happens if you go from a 2-studio environment to a 4-studio environment, 2 control rooms to 4 control rooms, but you're still sharing the same pool of resources? Expanding this to the REMI model even further, what happens if you need to do this dynamically? What happens if Studio 3 and Studio 4 and Control Room C and Control Room D are remote? What happens if they're on trucks and you need to spin those studios or control rooms up? You need to spin them down. What happens if they're multi-purpose? Studio 3 is HD in the morning, but it's 4K in the afternoon. How do you manage those types of transitions? How do you change all the settings of every device in your live production environment, whether it's located within the studio or at the remote site, or inside the machine room where your pool of shared resources exists? That is where a software solution like the Live Element Orchestrator comes into play. The Live Element Orchestrator is a broadcast orchestration tool running software that gives you centralized equipment configuration and setup. So one of the key features is that you can now save a profile that is HD, that includes all of the relevant production resources that are needed for your HD production. You can also save one that's 4K using the same resources, but Leo actually has the ability to switch the settings of those resources from HD to 4K on an as needed basis. In addition to being able to create those profiles, loading those profiles, and saving those profiles. You also have centralized monitoring in a consolidated area where you have visibility to everything that's going on in your production environment, whether it's local to the facility or it's remote, all by virtue of IP. And you have the ability to do resource scheduling. So think of booking a conference room in your facility where you've booked your conference room for your meeting from 8 a.m. to 9 a.m. and you want to hold that room and you don't want anybody else stepping on your booking. You can actually do that with the Live Element Orchestrator because it directly ties into all the resources that you need to successfully pull off your production, and no one else can touch it unless they have the administrative privileges or the administrative rights to do so. You can dynamically add resources and remove resources from the environment or from the scheduling. So as Jason laid out as an example before, a production switcher that's sitting in New York City, that's connected to the network, in theory, could be used by the facility in London that needs a production switcher resource. Because of the time difference, London can use that switcher to do primetime news. They can use it to run a primetime sporting event. And then when London goes dark and New York is waking up, New York can then take control of that switcher back and they can use it to run their morning show production, their morning show operations. The Live Element Orchestrator runs on a very interesting architecture. Here's a very simplistic overview of what's going on here. At the very top, you have your GUI and you have the application itself. The application is equipped with a number of engines, including a profile manager, scheduler, service manager, and automation. And by virtue of a device driver type methodology, we're able to integrate with every part of the live production environment. That includes the IP routing system, the camera system, your production switcher system, your production server system, monitoring, and third-party systems. So we are very much aware of the fact that we do not make every element of the live production environment. So we are working with third-party systems like character generators, multi-viewers, audio mixers, intercom, and so on, so that you have full visibility from a monitoring perspective and a resource allocation perspective directly from the Live Element Orchestrator interface. Here's just a few examples of the GUIs that you're going to expect to see in the Live Element Orchestrator. The GUI on the top left-hand corner represents just an image of all of the resources that are there, including the camera, the CCUs, the servers, the switchers, the monitors. If you hover over it, and I can't do it in this presentation, but when you hover over these elements, it gives you the latest status of each element, what its AV format is, if there are any errors, if there are any warnings. It can even tell you if the device is running in SDR mode or in HDR mode. And then on the bottom right-hand corner, what you're looking at is a network design interface. So as the network connections change, as the flows in the network changes, so let's say you hit a crosspoint button to change source A going to destination B, you'll see an active display of where those signals are going. And we see that there's a need for this type of application in the IP world. The more and more customers and clients that we've worked with who built IP systems, IP promises so much flexibility, so much scalability. But many people didn't think that once their IP system was implemented, they would wake up one day and be inundated with the number of resources, the number of signals that they have per device that exist within their single building. And then the thought of expanding that to multiple buildings or multiple facilities that connect into that IP network can be daunting. And the goal behind the Live Element Orchestrator is really to consolidate that into a single interface that's easy to use, easy to understand, and gives you the highest ability to create efficiencies with the pool of production resources that you have within your organization. So that brings us to the end of the presentation for the webinar. I am now going to open up the floor for any questions. And as I said, if you have a question, feel free to use that chat window, choose the two organizers and panelists option, and we will read out whatever questions you have. I actually do have a few questions that have come in. So if any, while we're addressing these, again, feel free to type in your questions. This first one looks like it's for you, Jason. So the first question is, are there any projects utilizing either of the mentioned workflows? I think talking to the examples that you gave in your presentation.
Yes, actually, yeah, thanks, Dion. And one of the things that we are working on right now is a situation where we have a television facility, and this television facility is kind of the headquarters for this particular group, and they're larger of their affiliates, and they have another affiliate that's about 90 miles away. So what we are doing is we are going to be adding in an additional switcher in an unused control room, and then remote REMI style, the cameras that are at the smaller station, so that the directors will be centralized, the workflow will be centralized, the number of graphic systems, the use of the graphic systems is better utilized and more efficient, and everything essentially will be extended from the smaller facility to the larger facility, and the larger facility will be doing the broadcast, similar to the style actually you showed in your PowerPoint of the two control rooms. They'll be located in the same television studio, just the production, the output of the switcher will be going to a transmitter that's 90 miles away.
Understood. Okay. This next one looks like it's also for you, which is, how does ELC control remote devices?
That's a good question. So the newest levels of our XVS switcher, in a combination with ELC and our XVS switcher, we control the device however the manufacturer of the edge device requires controlling. So on audio boards now, all of the camera control systems, it's all IP already. So it's able to utilize the existing IP connection to remotely control the cameras. And the audio board graphic systems are all IP based. If they're serial, then and the device on the other end supports the serial communication, then we can use a converter such as a Lantronix or type of device to do a serial to IP protocol conversion. That is based primarily on the type of device on the other end and what that protocol is. As an example, VDCP doesn't really lend itself to using an IP to VDCP converter, being strictly a serial protocol. However, many other things like AMP are IP based, so we can control servers through AMP protocol. It really depends on the edge device, but we have a solution and we have the products to be able to extend control over great distances if required. And it is part of our solution offerings that we can control things, whether it be near or far or a combination of both.
Okay. The next question is, how do these products deal with latency that will exist on the network? And that's a great question. I can take that one. There's two types of latency that we tend to look at for this type of environment. One is what we call, of course, your standard network latency. Again, laws of physics are finite. You can't defeat them. So if you go a certain distance, it takes some time for the signal to get from the source to the destination. Network latency is something that's very relative. It moves around. It can be high. It can be low. Some of our products, like our production switcher, have operated in environments up to 500 milliseconds of latency, which is very significant. But network latency is only one aspect. I think the bigger latency question that we often deal with is operational latency. And the question is, when the technical director, for example, goes to the switcher control panel and they go from source A to source B or input A to input B on the switcher, how long does it take before the technical director sees that change occur in the multiviewer or sees that change occur in the program output of the switcher? And in our testing so far, we've seen that it's been imperceptible by the technical director. We've done a number of proof of concept tests. One was from New York to London. We've done Las Vegas to Atlanta. We've done New York to Atlanta on a number of occasions. We've done Amsterdam to London. And we've been able to show that the operational latency is imperceptible. The technical director does not know that the production switcher is sitting in a remote site and the control panel is sitting right in front of them. They're able to run their production as normal. The only other consideration that needs to be taken into account is audio. If you're doing an interview, a mixed interview with signals that are local and signals that are remote, you may have to play around with your delays on your signals just to make sure that the audio syncs up with the video. But other than that, we haven't seen any real issues as it relates to latencies. Another question that's come in is, can you control third-party gear with the system manager? Assuming that that person is referring to the live system manager, the answer to that is yes, we can, by virtue of the protocols that are out in the market. You do have NMOS, ISO 4, ISO 5, ISO 6. They're pretty much done. 04 and 05 have been out there. We do support ISO 4 and 05 in our live system manager. 06 is still being rolled out to a number of the different vendors. We do not have 06 supported ubiquitously yet in our lineup, but that is on the roadmap. It is coming. So the LSM, by virtue of 06 and 05 and 04 NMOS, can support third-party devices. In place of NMOS, Sony had already developed protocols called NDCP and NSBus, and those protocols allow us to control our devices in addition to any third parties that don't support NMOS just yet. Some other questions that are coming in is, how would the director, and I think this is for you, Jason, how would the director who is not in a facility prep for a show?
That's a good question, and that is one of the reasons why everything that we're poised to do in the next generation of what we're doing with ELC is based on this remote capability. So as an example, the tool set that's built within iNews and EMPS is going to be HTML5 now. So the prepping that a director currently does that's ActiveX based will now be HTML5. So essentially that will allow somebody to log on and prep a show from anywhere, virtually anywhere in the world, not having to be in the facility. And of course, we already know, as we've been working with our partners for newsroom systems, such as the EMPS and iNews, we already know that they can extend corporate systems to communities, so that anybody from within a company, if permitted through permissions, can access any of the rundowns that are available within that corporation, or within that community, they call them. So technically, anybody could assist in breaking news from anywhere within a company, or they could actually prep the entire show.
Okay. We have an interesting question here on security, and I think I understand the question. I'm going to read it out loud. It's, while an expansive IP infrastructure offers a tremendous amount of flexibility to broadcast, it opens up a lot of questions on network security. For many broadcasters owned by large telco entities, this in itself is a very daunting task. How can you help win over cybersecurity scare? Okay, how can you? Okay. I think I understand the question with regards to how is security dealt with. I can tell you that from the Sony perspective, we've thought about this. We've actually already implemented cybersecurity in a number of different ways within our technology. For example, we do implement network authentication. We implement user authentication and device authentication. So the idea that anybody can just come into the network, plug in a device, and suck away your bandwidth or break into the system is not going to happen. We also implement standard IP or IT security layers like TLS, which is a standard protocol for security in an IT environment. And we also do things for stream protection and for denial of service attacks, where we do use things like QoS as a very basic level, where any type of unrecognized traffic gets the lowest priority within QoS and also does not get any bandwidth available to them that they can stream into the environment. So there are a number of protocols and things that we've implemented already because we've thought about this moving into an IP environment. However, there is a ongoing discussion right now. I believe it's NMOS IS09 and NMOS 10. Those deal with authentication, and they also deal with security on the network for an IP media system. Sony is an active part of those conversations with AMWA. So those will be developed in time. So those will be addressed in the near future. Another question is, what kind of bandwidth is required for moving signals around in HD or 4K? Is compression supported? I will take that one, Jason. Your standard uncompressed signals are still there. For HD, it is 1.5 gigabits per second. For 3G, it is 3 gigabits per second, and 4K is 12 gigabits per second. SMPTE 2110, as it stands today, is an uncompressed format, so there is no compression yet. I believe it is SMPTE 2110 It's either dash 21 or dash 23. Forgive me, I'm having a little bit of a blank moment right there. But there is a specification that will be a part of the SMPTE family that will allow for compression. I believe they're actually meeting about it as we speak. And there is a one compression codec, a JPEG XS, and there's also room for J2K. And other compression protocols like Sony's LLVC are being considered. So compression can be implemented in the IP system as well. I think we have time for one more question, and I already answered the question about latency. So there is a question, can Leo control every device in the live production environment? For example, multi-viewers, graphics, and replay servers. The answer to that question is yes, by virtue of what I showed on the slide, and this may have been asked before I showed that slide, is that by virtue of our device driver type methodology, we can connect to devices that are Sony devices in addition to third-party devices. And the question then goes, what about products from Sony's competitors? The answer is yes, we will connect and control to our competitors. Leo was actually built, or the Live Element Orchestrator was built in partnership with Skyline Communications. They have a product on the market called Data Miner. Some of you may be familiar with that product. We actually have a shared code base with Data Miner. So everything that Data Miner integrates with today, Leo can integrate with today as well. And as Data Miner expands, Leo will expand. So we are connecting to various products within the live production chain, including products from Sony and other vendors within the broadcast production space. Okay, we are just at the end of our time. I'd like to thank Jason for your time today in presenting. I'd like to thank our audience, anyone who was able to dial in and listen in on the webinar. If you have any additional questions or you would like some more information, please visit pro.sony and look up our IP live production page, which can give you a full layout of Sony's production portfolio, our technology. You'll also have the ability to download white papers about our technology, or feel free to reach out to your local Sony account representative, and they'll be able to connect you with anyone to get you some additional information. This webinar will be posted after we are done here, so you can always come back to it for reference. But again, thank you all very much for your time, and have a great day.